Okay, with subclass and superclass, it can provide polymorphism. We can write our own polymorphism and make use of the reuse class. Okay. So what's polymorphism? Polymorphism is when we can use the same method and execute on different actual data type. All right, so it's like we execute one method using one method name, but it can apply to different implementations or different classes. So I'll give you a couple of examples. So the first one is we can, override methods from parent class. Okay, there'll be example on that. And also the other example is about subtype polymorphism. So let's look at them. Starting from the method override. Okay, in class student, we have method printname, right? So in class graduate student, the method printname will be inherited. Okay, otherwise it will get the code from student. But we can override that. We can replace the code for printname within graduate student to have its own specific implementation, like in the example here. Okay, so the method that overrides printname also has exactly the same signature and same return type as well. Okay, so printname in this case has no parameter. Once we override the method, and also override in undergraduate student, we can see the execution from this first example. Okay, so undergraduate student can be created and then stored in variable of type student. Okay, you can create object of subclass and store it in variable of superclass. Okay, because the system thinks like this. The system thinks like, okay, how am I going to use S1 from now on? So S1 must only store data and method. Must say S1 must be able to use all variables and methods of class student. Okay, so storing undergraduate student is okay because undergraduate student object has all the variables and all the methods of student. So S1 can access and can call all of those. So the system allows you to do such assignment. Okay, and the same goes for graduate student and just normal student. Okay, but once we have S1, S2, and S3, once we have these, what does printname print out for S1, S2, and S3? So the answer is, S1.printname get us undergraduate students and the name, and S2.printname get us the correct print as well, according to what the actual object really is. Okay? So it gets us the correct print because of dynamic method binding. So the way the method is called, let's say S1 is of type student, right? It's of type student, but its address, well, remember S1 stores an address. Its address must or lead to the memory location where that location stores undergraduate student object. Sorry. Okay, so that's the situation in your memory. So when S1 called print name, it has two steps. The first step is it checks the type of S1. Right, it checks the type of S1. If S1 has, well, S1 which is a student. If student has print name, then it can proceed to step 2. Okay? Otherwise, it will generate error. Okay, first check the type of the variable. See if that type has the method. And then if that type really has the method, actually call the method. But call from the actual object. Class, okay, call method from objects class. So for S1, well, we have to check the system file. The system checks that student has print name. Okay, that's step 1, pass. Then it calls method from the actual object. That is, well, the actual object is undergrad student. So it calls method print name from undergraduate students. Okay, that's why it can call correct method. Okay. But it's S1 from now on can be used as both student and undergraduate student as long as it doesn't call functions or methods that specifically belong to undergraduate student. Okay? Even though S1 is actually an undergraduate student object, it cannot call method that's only available for undergraduate student and not in student. Okay, because the type dictates that. All right, the type dictates in step 1. If S1 calls the method that's only available for undergraduate student and not in student, it will not pass step 1. Okay, so that's what will happen. Okay.